Famous.
All right. Good. I think we're good.
I like just watch Face sits here because I can just copy off the screen.
All right.
I'll wait for the things ready for this.
So two things real quick that we spoke about in the past. We spoke about the cardiovascular system. And we said the cardiovascular system is like the key to several things. The instances of nutrition getting inside the body and moving nutrition around and moving gases around and moving a lot of different things around inside the body. It's made up of three different parts. Yesterday, I did not give you the third thing. I see it on this thing. I gave you blood. Obviously, it's a big component. Okay. The other thing that we spoke about, the tubes, are the blood vessels. Okay. Now, I believe this was your list right here, right? Yeah.
Yeah.
Your notes from yesterday were here. And I did give you the last thing. I did give my third period the last thing. So blood vessels, and one of the most important things will be the heart itself, the actual pump. Today we're going to get to a point where we talk about that pump and how the pump works and how the heart works. Some of you guys probably have a little experience talking about that, or maybe a lot of experience, who knows? And what you know, like how blood flows through the heart. How many people know something about that? Okay, a couple of people halfway raised their hand. So we're going to talk about that today as well. Okay, we spoke about the components of blood. I do want to not estimate the importance of this system. So as we kind of go back, I want to talk about two things about it. Number one, the entire purpose of the circulatory system, the cardiovascular system, is to move nutrients, gases such as oxygen and carbon dioxide, okay, throughout the body. But the other part, don't miss this part, is the aspect of what I just did there is I just made a sound. I scared some people. Some people were not paying attention. Some people were paying attention, but just a weird thing that just happened. But all of a sudden, you went from like maybe calm and chilling to an instant flight or fight situation. Okay? An instant flight or fight situation. And the reason why you do that is because I do not want to remove all these organs from this model, but at the back of here, try to do this without losing all my organs. I may have to lose them. Oh, he's a heart. Oh, so sorry. You okay? Sorry. But at the top of the kidneys, there are these things right here. They look like little fatty deposits. Those are not fatty deposits. Those are glands. Those glands are known as adrenal glands. They are responsible for, obviously, releasing adrenaline, epinephrine. Okay? As soon as I said, "Ugh," and scared some people, those guys secreted that, it quickly diffused into the blood. And not only that, literally within fractions of a second, you went from a state of, I'm chilling to, what I need to do. And that went from just these guys to all over your body, to your muscles, to your brain, your alertness, and all that happened in a fraction of a second. So the other part about this system is that why are these guys here? Because if you look here, there's blood vessels over here. They can quickly diffuse from these blood vessels to every part of your body, and it does it in a fraction of a second. So the way that these guys are able to also, the system itself is a transport for blood vessel, for nutrients, gases, but on top of that, hormones, signals, things such as insulin, in which the pancreas, which someone conveniently broke off of here, the pancreas has a lot of blood vessels in which it secretes insulin into the blood vessels. Okay? So all those things are critical. And in part of this part, I'm gonna make me a little cup of Joe while I talk to you guys. My throat is getting.
Watch out for the roaches. Yeah, don't make sure no roaches get in it.
Make sure no roaches are in it. But part of this, the other part of this system is the fact that it transports not just those other things, but things such as proteins, hormones, enzymes. Okay, it is the network for the human body. There's a couple of major networks This one is the major one. After that, we will talk later about the lymphatic system, which also transports and moves stuff through. Okay? White blood cells, so infectious diseases. Okay? The other thing is this as well, is that like I told you, the blood is the key to the human body. Like if we talk about like eating food, you have two things that happen in the digestive system. The first part is digestion, which means to do what? To break down. That's what digestion means, to break down. And the second thing that the digestive system must do is what? Absorb. What does absorb mean? What does it have to absorb to? What does it absorb to? So what? The blood. The answer is nothing is inside of you until it gets into your bloodstream. For the alcoholic that drinks, that alcohol is inside the stomach. That person's not drunk because it's in their stomach. That alcohol has to get into the blood. As a result, we check what we call the alcohol blood content, blood alcohol content. Okay, that's what the officer is trying to check. Hey, blow into this. They want to know how much alcohol is in your blood because if it's in your blood, it's in there. It's getting to your brain. If it's in your blood, it has network to go everywhere. And obviously, the big thing that controls that alcohol aspect is this thing right here, your brain. So if it's in your blood, it's going to your brain. Okay. The last class, I mentioned a couple of things. My stepfather is who raised me since I was like 2, but he's going through prostate cancer. He has prostate cancer, and he's going through the process of it. There's another teacher here at Springwoods who's dear to me. She had 2 daughters that went here. The last one just graduated like last year, and she's battling right now breast cancer. And we were talking about the importance of like this system when talking about cancers. And I told them, I said, well, prostate cancer, this is a male reproductive organ I'm holding here, obviously. I mean, I know some of you know, you young ladies should not have seen this yet. But this organ right here, okay, I just took this and I opened it up. This is the male's urinary bladder. We do not have a uterus because we don't have babies, okay? This is the urethra that goes out through the penis. And then there's some other stuff that's there. So I always ask people, I was like, well, what is the prostate gland? I mean, is it because the prostate gland is like really important? It does something like it's a critical thing? And the answer is like, per se, not per se. Here is the prostate gland. Here's the prostate gland right here. This little walnut-sized gland right here. In fact, if I was to take the other side of this, here's the other side of it. So what the prostate does is that it encloses, the urethra goes right through it. Okay? The urethra goes right through it because this gland serves a reproductive function for males. The secretion from this gland dumps into the urethra, like the secretion from these things, together the right way, hopefully. The secretion from these things, known as testes, make, which is sperm, and the secretion from these seminal glands, and another gland called the bulbourethral gland. All those glands secrete at once to create semen, which happens during reproduction. Okay? This gland makes one of the components of it. Is it critical? No, not at all. So why is prostate cancer, by the way, and I was listening, and I say this, I was literally, yesterday, I listened to NPR in the morning, I was listening to a story on prostate cancer yesterday. It was talking about how the cases are so big and so many people are suffering from it and how you have to catch it early. I was talking about like I told you, my stepfather who has it, he's fighting it, and he was going through radiation for it. And then he stopped for several reasons. Explain that. Okay? And what happened here, this prostate cancer, And what happens to it is two things can happen. Is that it's not because I told you the prostate is like a really special gland as far as like men being able to live. But here's what the problem is, which links back to our unit. And that problem is the fact, maybe it won't let me do two things at once. If so, that just stuck out. The problem is the fact that this gland is close to a lot of blood vessels. There's a lot of blood vessels over here. In fact, these little dots, some of you guys can see these. These little dots are blood vessels that, like when I open it, will simulate like I kind of separated them. But there's blood vessels all over here. What happens in prostate cancer is that the cells inside the prostate, they go rogue. They start replicating on their own. They start taking over. They start requiring more nutrients. And the reason why it's a big issue is not because of the prostate itself. There are some issues that can happen. Like, for instance, this just covers that urethra. It makes the male have to urinate way more frequently. And sometimes it can get so enlarged, it starts squeezing that tube. So then on top of that, when you're urinating, it makes it like, instead of trying to pee through like a regular straw, you're peeing through like a coffee straw. And there's nerves around there, which could be very painful. But the big issue is not either one of those things. The big issue is the network. That gland is around a whole bunch of networks that leads to the rest of the body. If those cells start growing so completely out of control, and if this is the network right here, what those cells can do is that they can get on that network, and from there, they can go anywhere. What I mean by anywhere, I mean they can go here to the heart, they can go here to the brain, they can go here to the kidney. So they can go to critical places, and at that point, just to be honest with you, if that does happen, at this point in time in our medical world, there's nothing we can do. At that point, it's inevitable. That person is about to die from cancer. The whole process is to stop it before that happens. With breast cancer, the whole process is to try to stop it before, just like the prostate gland, mammary glands have a lot of blood vessels around it. And the issue is not the fact that that gland it is important, obviously, in like the nurturation of babies and things of that sort. And obviously, we have put like a cosmetic value, I guess, on that. But the issue is the fact that there's a lot of blood vessels there. And once those cancer cells get on the blood vessels, it's not about the breast. At that point, it's going to affect everything. And once it gets on the network, medically, we don't have an answer. Okay? So the circulatory system is a critical system for that. It's a network system. It determines like what's inside of you, from, like I told you, viruses and bacteria and things of that sort. But then the other part, on top of that, we spoke about cancers. Just the last hit on this unit is not over cancer, but the last hit on this, what these that makes it such a bad situation. Because remember, the prostate gland, the breast, they're ours. What I mean by that ours is that the treatment for my stepfather's, my old man's prostate cancer involves taking radiation and they apply it right here. That radiation focuses on this area, and the issue with this is that it destroys cells. The ideal is to destroy as much cancer cells as you can. But understand, in this process, you destroy good cells because understanding the fact that the cells that are causing the issue are yours, which is completely different from other issues with us. If I have a cold, it's because I probably have a bacteria or a virus that's infecting me. Your body identifies that these things are not part of you. Your body, you may get sick, but your body's fighting it. There's white blood cells going around like, hey, you're not supposed to be here. Hey, antibodies, attack them. Let's go get rid of them. Viruses are not supposed to be here. Your body's like, hey, it's a virus. Guys, antibodies. Tag this thing up. Let's go get rid of it. The problem is, it's your cell saying, hey, what's wrong? So your body's like, what we do? You guys are going rogue, but you're us. So the issue is we're killing something, but in the process, we kill also good cells. My old man, he stopped this process because of two things. That radiation not only affected this prostate and killed some of the cells there, it started destroying all this urethra. Like this tube. That's the P tube for us, and amongst other tubes. We only have one tube, ladies. Unfortunately, we're very simple. Which makes our minds, I guess, very simple. But this one tube, it started getting infected. It started breaking itself down. The tissue started breaking down. And he said, I couldn't even pee. I was talking to him literally like a week ago. I was like, hey, why don't you stop your treatment? He was like, man, you don't understand. He's like, I couldn't pee. Every time I peed, it was like the worst pain I ever felt. I was like, what? He's like, and then I called my mom. My mom was like, no, she was like, he'll wake up in the middle of the night. He's like screaming because that tissue started breaking down. And it got to a point where he just said, hey, I'm not doing this radiation anymore. Which is my next question. Like, hey, if you're not doing the radiation, the cells keep growing and they can get, like I told you guys, on the railroad track, which means that, like, they can't do anything after that. And he was like, hey, this pain, and this guy's tough. Like, this guy fought in Vietnam. He was like, I just have to figure that out when it happens. I have to pray and just think about it, and I can't do what I'm doing right now. Like, he like literally made a life choice because of that. So the hard part of it is that you're killing your own cells in order to try to get rid of like your cells that are going rogue. Same thing happens with breast cancer. Like that teacher I was telling you about that here, I saw her this morning. Obviously she's going through chemo. There's no radiation for breast cancer, chemo for it. And her hair is obviously gone. She covers her head up, and and it's tough. It's hard. That process is hard. And all we're trying to do is just make sure that those cells just don't get on the circulatory system, don't get on the railroad tracks. Because once they get there, they have access to everything. Everything, every organ, every spot. And once it's there, it's just too broad. We can't do anything. We just don't have the ability to do anything at that point. So that's where we're at. We spoke about several things. We said the red blood cells are the reason for the season. And they are like the big part of why things happen inside the circulatory system as far as oxygen and carbon dioxide is concerned. And we said that red blood cells contain a molecule known as hemoglobin, and hemoglobin bonds to oxygen and to carbon dioxide. It has the ability to bond to oxygen and to carbon dioxide. We also said because of this hemoglobin molecule, mature red blood cells do not have a nucleus. They do not have nuclei. The other thing about these guys is that these guys also have another affinity. I did not talk about this yesterday for something other than oxygen and carbon dioxide. And it turns out, like if some people, many scientists will say there's a big flaw, a big default, a big problem with hemoglobin, because what it does, it typically bonds to oxygen in 4 points. It has like, if I have my arms and my feet could connect to oxygen, each hemoglobin has 4 connection sites for oxygen and carbon dioxide. There's something that it loves way more than both of those. Okay? And as a result, if you breathe it, and it's just a very small trace of it, it's going to move the oxygen out the way and say, oh, give me this, because it loves bonding to it. And that is, you might know what it is? Carbon monoxide. And you know what carbon monoxide does? It kills you. So as a result, you don't need a lot of carbon monoxide inside of a house or inside of a room in order to kill people, because your body will actually, that hemoglobin will actually move other stuff out the way and say, oh, give me this. I want this. And it'll take it right to your body and it will kill you. Okay? Where's carbon monoxide made from? Every combustible thing. Car engines, motors, generators, barbecuing. Okay? So if you're just thinking like, you know what, I'm going to go barbecue indoors. Okay? That would be a very bad idea. Very, like a deadly idea. Not a good idea at all. Okay? Why don't people barbecue indoors? Because carbon dioxide is produced in that situation. Okay? All right. So that's important. Hemoglobin was the reason for the season, and here's what the issue was for it. Well, I told you, and this is where we stopped at inside your class. I said that hemoglobin, when it's connected to carbon dioxide, is a dark maroon color. Through the skin, it looks blue. So if you can look, I don't have long sleeves, but if you can look, okay, obviously the lighter your skin complexion, the better you can see this. Through your arm, if you see red blood vessels, those are blood vessels that have a lot of oxygen present. If you see blue ones, those are ones that are lacking oxygen but high in carbon dioxide. Lacking oxygen but high in carbon dioxide. There was a condition known as blue baby syndrome that was common, which led to death, because what happens with these babies is that a tube of oxygenated blood never got to the rest of the body. As a result, it just kept recycling deoxygenated blood through the body. And what the babies that were born with this condition would do is that over time, they'll just start turning blue in the face because they had that much deoxygenated blood inside of them. It's a story of Dr. Vivian Thomas, who was the doctor that kind of set everything into play in order to fix that disorder. If we ever had time, we'll go by. That's a very good movie called Something the Lord Made that kind of goes over his story, because it's a good movie. All right, is everybody cool with that? All right. Aside from that, I already wrote this down, so I'm going to kind of cheat. And here's how this cheat goes. What you need to write down. The first thing I put away and towards. Our highlights, not away and towards. Our highlights are these two words right here: arteries and veins. Okay? And here's how the story goes. Every artery, what defines an artery for the human body. So now we're talking about the tubes. Arteries always pump blood away from the heart. Every artery. If it's pumping blood away from the heart, it's an artery. If it's pumping blood away from the heart, it's an artery. If it's pumping blood to the heart or towards the heart, it is a vein. So most arteries are what color? Red. They usually have high oxygen levels, except for one. There is an exception. And most veins are blue. They usually don't have a lot of oxygen content, but they are pumping blood towards the heart. The reason why I'm saying towards the heart, because as we go through this cycle, there's going to be some vessels going to the lungs. And a lot of my students get very confused with calling arteries things that leave the lungs versus things that leave the heart. Okay? Remember, all blood somewhere has to go to the lungs. That's how you get oxygen. Okay? When we do these, guys, it's not the human body. These are from largest to smallest. The largest blood vessel that are arteries inside the human body is the aorta. The aorta is connected to the heart. After that, we have little vessels that we call arteries. The ones that are smaller than that are known as arterioles, and arterioles feed into capillary beds. For veins, these guys have low oxygen, high carbon dioxide. They appear blue in coloration. Okay, the largest veins are known as the vena cava. There's a superior and inferior vena cava, and both of those guys are connected to, if you guessed it, the heart. The largest diameter tubes are stuck to the heart. are tubes that lead from the heart. Okay? After that, there are veins. From there, we call them venules when they get thinner. And then after that, they get to capillary beds. If you notice, there's two things that are shared by arteries and veins, and those are capillary beds, because capillary beds are where the gas exchange, the nutrients exchange, all that stuff takes place. Capillary beds. What are capillary beds and how do they look? Well, if I was to cut myself right here and start to bleed a little bit and later stop, okay, that means I just cut a capillary bed. That's where all nutrients and stuff is taking place. Capillary beds are generally shallow. Now, if I was to cut my arm right here, I just kept bleeding. That means I probably cut an artery or a vein, more than a capillary bed. Okay? In some of those cases, you may have to have some help in order to stop that bleeding. Does that make sense? So capillary beds, when you cut those, they're so thin that they can kind of close and coagulate on their own and stop the bleeding. When you start cutting veins and arteries by accident, or I guess inadvertently or inadvertently, okay, those guys, many of them, you'll need some medical help. Like there's a large artery known as the femoral artery. It goes along, obviously, the femur. If that one right there, doing like any type of leg injury, starts to bleed out, it has a large content of blood. Okay? You can die from it. Anybody lost with that? Everybody's cool with that. Okay? All right. Which now leads us to our next thing. We kind of fast this. I'm going to draw an original picture for us. I'm not going to use one from last picture. I think it's important that you see how I drew it. Okay? The two things that are important about this is the location of the heart. The heart, we're going to draw a picture of the heart. In our picture, it's going to look like this. So we have the external anatomy of the heart, what you're looking at right now. The external anatomy is very important. In fact, with the external anatomy, you notice that there's blood vessels right here. Okay? The red ones, guess what they are? They're called arteries, and these blue ones are veins. Okay? And these guys actually feed the heart. Although the heart pumps blood, it turns out in order to pump the blood, the heart needs blood. So these little veins and arteries are known as coronary arteries and veins. Okay? We'll talk about these guys later. We'll talk about the outside of this guy later. These are the reason, though, for heart attack and heart failure. We talk about like you have to have like a bypass surgery and things of that sort. It's because these guys get blocked up. They are very thin arteries, very thin veins that can easily get clogged up. Okay? Notice also at this yellow stuff, this is fat. Can you get that from me? This is fat around this heart. Okay? Fat is needed on the heart. Okay? However, I do want you to understand there are situations in which this heart can have so much fat that it's covering the entire thing. If you guessed it, you're probably right. That's very unhealthy. Okay? But it's also unhealthy to have no fat. Turns out that we need a degree of fat in order for the electromagnetic signals to travel correctly through the heart. So no fat is also not a good sign. Okay? This man like this, like you see on this model, is pretty generally healthy. Some people have so much that it covers their entire heart. Some people also say, well, that must be like a big person if you have that much fat around your heart. And that's actually not the case as well. There's a recent case in which someone died. This guy worked out on a regular basis, big muscle guy, died from heart failure. They opened up his cavity, and his entire heart was just covered with fat. So here's a guy with like very low body fat percentage, but his heart was covered with fat. So it doesn't deal with like just like if you're a healthier person, like a bigger person, whatever. Okay. Also, smaller people. It really at that point, a lot of it depends on genetics and what you eat. Okay, what you put into your body. All right. So our heart, we're going to draw the heart in which we cut it open. And here's how we're going to start this picture up. I'm going to go black. Some of you guys use different colors. I like using different colors. So I'm going to go here. I'm going to go up and around and curve it around. And I'm going to go like that. Once you get there, just relax. It means something. I know some of you guys just love taking pictures. You're like must be like future photographers of America. Okay? But it really does mean something. I say this all the time, it means something to draw something. It just means something. You mentally there's a mental neurological connection when you write something or draw it yourself. I'm glad that when I met my wife that cell phones didn't exist because not we definitely wouldn't have got married. But that's how our story started. I saw somewhere, I was like, hey, you gonna take that? Yeah, I'm gonna take it. I was like, yeah, I'm gonna take it. I haven't seen you, blah, 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 talking. And then I was like, hey, so what's your number? She's like, you got something to write it down? I was like, no, it's our memory. I have a good memory. Like, if it was a time of like cell phones trying to program stuff, I would have easily, like, if I lost my phone, I would have, I remember. Something about making connections, writing stuff down, and trying to memorize stuff just makes a big difference. She was blind, of course. That's why she married. I was like, hey, what's your name? She's like, who are you? How do you look? I'm like, I really like Denzel Washington. Could you tell from my voice? And she was like, oh, you must be cute. I was like, yes, I am. And then like someone told her like, ooh, you been dating him? She's like, ugh. All right, I'm gonna draw a couple of things now. I'm gonna go here. And draw our first cavity. I'm gonna go over like that. Use time to draw that. Notice if we do this in pieces, I think everybody can have a pretty decent looking heart. Even you, Anna. Then after that, I'm gonna go around here, go down, around, and up. I'm gonna make this thing go like this and up. I'm gonna stop that tube just like that. Looks almost somewhat complex now. After that, I'm gonna go on this side. I'm gonna make another cavity just like the one at the top. Looks exactly the same. Make it go around like so. Then after that, I'm gonna have a bottom one just like I did at the bottom on the other side. I'm gonna go down. And then what I'm gonna do is something weird. I'm gonna go here. I'm gonna put a dotted line to show that it's going through this tube right here, or crossing through it. And so I'm gonna close this off right here. And here's what I'm gonna do after this. I'm gonna take the tube, the second one I just drew. I'm gonna come here. I'm gonna go around. I'm gonna make 3 little tubes come off of it. I'm gonna cut those tubes off. And then I'm gonna have this tube come down. So that tube is gonna go like this. And then I'm gonna stop this tube right here. And the reason why I'm stopping it is because the first tube I drew, I'm gonna make it go like this. But that first tube I drew is gonna go to the right and left. It's gonna split to the right side and left side. So it's gonna go out this way. You didn't realize this was art class. And then at the very end, this tube that's going around, I'm gonna make it come back down here. And I'm gonna cut it off right there. I'm gonna kind of let you catch up for a second. I'm know you like, well, kind of went fast, didn't you? Sorry. So if you saw I did, this one goes here, this tube goes out here, to the right, and to the left. But the part that's kind of hard that I had to explain, that this tube goes here and around it. So when this will go left, it goes underneath that tube, and it goes right. So what's happening here is that it's this right here. Here's the tube going around, and this purple, that's the other tube in which it goes this way. The other part goes here. You can see it coming from the back side right here. Okay. Got a couple more tubes on this. All right. There's another tube that goes from the back. It's a very big tube. I cut it. It goes like that. It feeds into this chamber. So I'm going to put the hole, the opening inside that chamber. And then there's another tube that comes down from the heart. And that one feeds also into that same chamber, but right here. How are we looking? Looking pretty good. Now, after you do that, okay, I'll wait. I'll wait. A lot of pieces to this thing, man. In order for it to work, this thing, your heart is inside of you, beating every single second. Millions of times in your lifetime. It's an amazing thing. You think about biological flesh, you always think about weakness. You know, like you take the human and then the transformer, you're like the transformer. That's the thing you want to be. You know, if you're a transformer sci-fi guy, you're like the transformer, man. Car has to be tougher than the human. Then you start thinking, I've only been alive on this planet for 40 years. I have had, at least in this time period, at least 6 or 7 cars since I've been on this planet. Most of those cars that I had were clunkers. They broke down. They stopped working. Metal, engines, combustions, hard physical things broke down. Yet here I am, still living. My heart that has to pump every single second, weak flesh, as they will call it, has not failed. For some people, this weak flesh will continue to work for over 100 years. What's really weak and temporary? The metal, the car, the soft biological heart. 2 more tubes coming out this side. These are not very big. And all 4 of those tubes go into this chamber, which means like these will go into here. There'd be these 2 holes, and these 2 go behind the heart and into those 2 holes. So the ones on that side do not go into that side. They actually go behind the heart and to that other side. The other part that's in critical part, this is what most people get lost with this, why I tried to explain to you at the very beginning of the class, anatomical rights and lefts. This image is the image of the heart being faced like this towards you, which means you're seeing the anterior side of the heart, which means it's like the heart inside of me. Your heart goes here and around to the side. Your heart is not on this side of your body. If you look at this model, the heart's in the middle, but what happened is this apex, this part right here, comes over to this side. It makes it that the heart's in the middle, okay, takes up a little bit of lung space over here, so you actually have less lung folds on this side than this side. You have, on this side, you have 2. This side, you have 3 lung folds because the heart, the apex, goes over to that side. However, the heart is in the middle of the chest and then curves over to that side. This is the anatomical position, which means this. This for our heart is the right side. This is the left side. Please label your pictures accordingly. The cavities are the chambers inside the hearts. They have names. These are known as atriums or atria. That's one, and that's another one. Okay, that's the whole drawing. There's some more stuff, but I'm going to add it as we go. The one on the right side is known as the right atrium. The one on the left side is known as the left atrium. These guys at the bottom, the cavities at the bottom, they are known as ventricles. If you guessed it, the one on the right side, they are the right ventricles. The one on the left side, they are the left ventricles. This area at the bottom is known as the apex. This middle separator is known as the septum. These things right here in the middle that separate the atrium from the ventricles, they are valves. Those valves, the right side and the left side, overall are known as atrioventricular valves. Atrioventricular valves. They're on the right side and left side. However, when we take our journey, they have specific names to them. Like one of those valves on one side has 3 leaflets on it. So as a result, we call it the tricuspid valve. Another one has 2 leaflets on it. So we call it the bicuspid valve or the mitral valve. And we'll talk about those guys as we kind of move through. Everybody's cool with that? All right. I'm going to start off a story. We will not be able to finish the story. I'm going to get as far as we can with the story, and here's how it goes. Okay, I'm going to lay some tubes with this as we kind of go through. And I'm just going to just start the story off. I get it. The bell's going to ring. So blood has to enter to the heart from the top of the body and the bottom of the body. The top of the body because blood is draining from here, and the bottom of the body because it's draining from here, and the heart is in the middle. That's these 2 tubes on this side. So blood enters into the heart going this way, and it enters from the bottom going this way, and we'll finish this story the next time we meet.